All right, so welcome back again for Calc 3 here. And again, this is for worksheet 4.4, but this is part 2 now. So I left you at the end of the first video here that dz, printed dz, is equal to the partial derivative of dx times the printed dx plus the partial derivative dy times the printed dy. Okay, to use this to approximate values. Okay, so just like I did a tangent line approximation last year, same thing. You have this scenario here. So let's do an example now. Okay, so let's say we have, let's say, remember, z equals f of x comma y. Same thing there. So we have x squared plus 3xy plus y squared. Okay, so before I give you numbers here, let's get everything set up here. So let's say let's go ahead and find the partial derivatives here. So let's do partial derivatives. So let's go. So let's do this way. Partial derivative dx. So that would be 2x plus 3. Okay. Oh, 3y. Almost forgot that. Now the partial derivative of dy would be, what's that, 3x minus 2y. Okay, so those are the partial pieces. All right, so here's the problem. Okay, so my point of my plane is at 2, 3, and I want to approximate the point that's close to that of 2.05 comma 2.96. Okay, all right, so first off, let's go ahead and find the equation of this. So you would have dz, partial derivative dx, let's do this way, 2, 3. So what we have there, 4 plus 9, 4, 13. Partial dy at the point 2, 3 would be 6 minus that. Is that right? Minus 6. Is that right? Looks like 0. Just double checking myself. Okay, so the equation of this would be z equals, or let's say dz. So my slope would be 13 dx minus 0 dy. So what is my change of my x's? Well, my dx, my change is from 2 to this would be 0.05. My change in my y, even though it doesn't matter because it's 0, but I do want to talk about that. So what's change of my y? Well, that would be negative 0.04. So plugging this in, I'd have 13 times 0.05 minus 0 times negative 0.04. Okay, so what is approximate difference, okay, that would be 0.65. Okay. Now, my original value here, if I come back to this and I said, okay, my f of 2, 3 was 13. Okay. Now, if I plug in my equation for my tangent plane, okay, I'm going to get off, and like I said, if I wrote this equation out, I'm going to kind of keep it quick here, so 2.05, comma 2.96, I would get 13.6449. And notice the difference between this. Now again, this is as approximations here, but notice that I was off about 0.65 if I round, which is like this. Okay. All right. Let's do another example here. All right. So let's say we have we use this linearization. Oops. Linearization to approximate or estimate this value here, 3.99 to the third and 1.01 to the fourth and 1.98 to the negative 1. Okay, so what I'm going to say here, let's say I don't have a calculator to do this, so I want to try and come up with some maybe a little bit easier way than to multiply all that out. So I'm going to do the same thing here. I'm going to come up with an equation of that f of x comma y, but I have a third one, so I'm actually going to add another letter into this, x, y, z. So my equation is going to be x cubed, y to the fourth, and z to the negative y, or negative 1. And what I'm going to do is I'm going to do approximation of around 4, 1, and 2, close to each one of those numbers. Okay, so what I got to do here is I got to do the partials of 3 different things here. All right, so my partial of x would of x, y, z, well, that would be just 3x squared, y to the fourth, z to negative 1. So if I plug in the point there, 4, 1, 2, and I'm going to do it 24. So now partial of y of x, y, z. So that would be x cubed. So now that would be 4y cubed, z to negative 1. And the partial of y of x, y, z. That would be 128. And partial of z, kind of out of room here, so I'm going to keep it short here. So it would be x cubed, y to the fourth, and this would be negative z to the negative 2. So therefore the point at this would be negative 16. Okay. So again, so my slope here is 24, 128, and negative 16. Okay. So I'm going to use, I need something to come up with here. So I'm going to use W here. I'm up here. So my approximation here, dW. So this is not the actual plane. This is the error factor here. So we would have partial derivative of x dx, the change of that, plus partial derivative of y, printed dy, change in my y, plus partial of z dz. Alright, so if I plug in here for my error factor, this would be 24. Now how far off of x values is this? I should come back up here. Let me find a different color here. So what's my difference of my dx's? Well, the difference between 4 and 3.91 would be a negative 0.01. What's the change in my y's? dy. Well, that would be 0.01. And what's the change of my z's? dz be negative 0.02. So coming back in here, this would be negative 0.01. My slope 128 would be now 0.01, and negative 16, and we change to negative 0.02. Okay. Now, calculating all this out, you should come up with 1.36 would be my error. Okay. Now, if I actually go through and plug this into it, and if I find f of 412, you should get 33.36. That's the correct answer. Okay. Now, if I did my tangent plane and found that equation and did it by point approximation, so if I went w of 3.99, 1.01, 1.98, and plug that into my tangent plane, and basically I just have to put in what my dy is and add it or subtract it to the other side, and I would get 33.3840. Okay. All right. In terms of looking at the two values, anyway, error factor is between them. Okay. All right. Let me show this. So let's do the tangent plane with that exact same scenario here. Okay. So let's do that. Let me show you on that one. So we had a point 4, 1, 2, but now we have a z value of 32. So there's my point. And my slope was 24, 128, and negative 16. That's from all from up here. Okay. Okay, so now let's go ahead and do tangent plane. So we have an equation here. So now, I don't know, let's say alpha linearization of x, y, z. Now we have three variables. I guess we could use w, I guess, too. Now let's use w. Okay, so my slope would be 24, x minus 4, plus 128, y minus 1, minus 16, z minus 2, and then plus 32. Okay. Now again, you could have went, W minus 32 equals, and then move the 32 over. I just did it all in one shot. All right, so cleaning all this up. Okay, so the W of x comma y comma z, you should get 24x plus 128y minus 16z minus 160. Okay, and like I said, if I plug in 3.99, 1.01, and 1.98, I would get 33.36. Okay, so could I do with this with more variables? Yeah, it doesn't matter how many you use, you just keep adding variables to it. Okay. Let's go through another example here. Let's see, I'm going to post all my notes, so I'm just looking. Let's do one more, and then these to compare to. All right, so let's say I want to calculate the error when finding volume. Okay, so last year you did, let's say, volume equals pi over 3 r squared h, and you did different things in terms of related rates with this, volumes, things like that. But when you create a object of this form, you have materials and plastic or metal or whatever you make your water bottles out of, for example. But you might find a certain volume, but you have an error factor of your materials. So let's say if you're design, say, a water bottle of a radius of 10 centimeters, and say the height of my water bottle is 25 centimeters, there could be a possible error factor of say 0.1 centimeters. Okay, and the reason of that error factor would be your materials. Now it could be higher, lower, whatever. Kind of depends on how you're working with this. Okay, so to find the error factors, how far would I be off? Well, let's say dV. Well, this is where you do your partial derivatives. So let's say the partial derivative, now you have two variables, r and h, so the partial derivative of, say, r times the difference of dr. Now the partial derivative of h times the difference of h. That would give you your error factor. Okay, so if we go through and find this values here, so the partial derivative of this. Okay, so doing the derivative of this piece here, you would have pi over 3, 2r h. And then you would have the difference of your radius. Okay, so plus, now doing partial derivative of h, the derivative of this, that would be pi over 3 r squared, and then the difference of your error, dh. All right, so plugging values in here. You would have pi over 3, and it'd be 2 times 10. My height is 25. Now, what is my error factor? My error factor between my radius and height would be 0.1 plus pi over 3. Now my r would be 10 squared. And again, what's my error factor for my materials? 0.1. So if you go through all this and simplify it, you should get 20 pi would be your error factor. So that's how much you're going to be off on your volume in terms of, you say, okay, my water bottle holds 1 liter of liquids. Well, you technically would not be accurate to that. So it'd be an error of, and again, that'd be plus or minus of your error. Okay. Now, let's use in terms of equation of a line. Okay, so how do you write an equation of a line? Well, you need a point and a slope. So let's find the point. And again, we're using the same equation here. My point would be 10, 25. And if I plug that in, my volume would be 2500 pi over 3. Now, my slopes, and I'm getting my slopes from here and here. My slopes would be 500 pi over 3 and 100 pi over 3 are my slopes. Okay, so now let's write the equation. So it would be z minus 2500 pi over 3. And like I said, I'll move that value over here as soon as I plug everything in. My slope, 2500 pi over 3. And then it'd be x minus 10 plus my slope, 100 pi over 3, y minus 25. Okay. And clean this up a little bit. Like I said, where I might clean this up, would move this to the other side. Okay. So I'd have z equals, and now let's just rewrite here. So 500 pi over 3, x minus 10, plus 100 pi over 3, y minus 25, plus 2500 pi over 3. So if you look at this piece here, there's your error. Okay, and that's what we just did up here. Okay, so here's my actual volume. That's what my volume is without my error factor. So you had your 20 pi here, and then depending on, it's going to be actually like plus or minus what we have there. Okay, actually the plus minus should be with this. Okay, that should be a plus. There you go. So plus or minus 20 pi plus what your volume is. So anyway, so hopefully that gives you a little bit of an idea of how this works. I do have another example on my notes that I'll be posting, so you can take a look at that. Pretty much the same exact thing. But it gives you a little bit more ideas, try to look at a pattern there. And again, how do you write equation of a tangent line? Point and slope. How do you write equation of a tangent plane? Point and slopes. Okay, and remember the z part is the actual value, and the other part is the error factor. All right, so hopefully